Okay, in this section we're going to look at mathematical models, building functions from applications. On page 120, I thought the best way to do this section was just to do a bunch of problems that were in the book for practice. On page 120, problem 2, it says that let P be a point on the graph of y equal x minus 8. Okay, so part A, express the distance d from P to the point 0, negative 1 as a function of x. Okay. Well, I've got this curve, this parabola, y equals x squared minus 8, and a point that's not on the parabola, it's on some other, just a random point, I guess, and there's a point on the parabola, and I want to find the closest point to 0, 1. Okay, and of course using symmetry there's going to be 2 points here as part of my answer. D of x, the distance, is x minus 0 squared times y plus 1 squared. Now y is x minus 8. Okay, so where it says y, I'm going to replace it with x squared minus 8. And that's x squared minus 7 squared. Boil that. So I got x squared plus x to the 4th minus 14x squared plus 49, the square root of that whole thing. And that gives me x squared minus 13x plus 49. Okay? And that would be just a function that models this situation here. Problem 2, what is the distance if x is 0? What is the distance if x is negative 1? Okay, and then we'll do part D and part E together there, since we'll be using graphing utility. Well, part B, the distance when x is 0. So when x is 0, it's going to be 7 units, and that's what I get. The square root of 49 is 7. The distance when x is negative 1, negative 1 to the 4th is 1. Minus 13 is negative 12. Plus 49 is 37. The square root of 37 is approximately 6.08. Okay, and that's if x is negative 1. Okay. Minimize the distance d of x, which is the square root of x to the 4th minus 13x squared plus 49. Using a TI-83, and I plug that in. So I've already got this typed in. Okay. Second trace. Minimum. So, and by the way, the answer here using symmetry, since this is an even function, is going to be the same. Well, the x value is going to be different. The y value is going to be the same though, and I can see that from my picture. If I use one bound, x is negative 2.55, y is 2.6. Okay, so using symmetry on the other side there, 2.55, 2.6. So the distance is going to be smallest when x is negative 2.55 and when x is approximately 2.55. Here's another one, problem 4. Let xy be a point on the graph of y equal 1 over x. Okay? Express the distance d from P to the origin as a function of x. And we'll answer parts B and C come together. So here's a graph of y equals 1 over x, and point P is xy. And I'm at 0, 0, and I want to find a point P on the graph of y equals 1 over x that's as close to 0, 0 as I can get. So what values do you think are closest at first? Well, it looks like 1, 1, and negative 1, negative 1. So the distance, x minus 0 squared, plus y minus 0 squared. Y is 1 over x. So I got the square root of x squared plus 1 over x squared, which gives me the square root of x to the 4th plus 1 over x squared. Okay, and I want to minimize the distance. So the distance using my calculator here, I get, whoops, let me see, square root of x to the 4th plus 1 divided by square root of x squared. Okay, so second trace, want to find the minimum distance. Okay, so I have a graph that's symmetric about the y-axis here, which means that it's going to be enough to just find one of these. So y is 1.41, x is 1. Okay, and another distance here would be negative 1, 1.41. Okay, and 1.41 is root 2. Yeah, it makes sense that x is going to be 1 and negative 1. We had guessed that. Root 2 and negative root 2 was at these points. Okay. Problem 6 says that a right triangle has one vertex at the origin, at the graph of y equals 9 minus x squared, x is greater than 0, at x, y, and the other is at the origin. And the third, on the positive x-axis at x0, express the area A of the triangle as a function of x. Okay, so I got x, y. X is positive, and x is on the positive end of the x-axis. Y is positive. X is not given to me. Y is 9 minus x squared. So I got 1/2 times xy, which is the area of this triangle, and 1/2 xy. Well, y is 9 minus x squared. 1/2 x times 9 minus x squared. If I distribute the 1/2 x, that gives me 9/2 x minus 1/2 x cubed. And that's all they're looking for there. Okay, problem 8. We'll do problem 8 here, and then I think we'll call it good. A rectangle is inscribed in a semicircle of radius 2. See the figure. P is a point xy, be the point in the quadrant 1 that is a vertex of the rectangle and is on the circle. Okay, so part A, express the area A of the rectangle as a function of x. Okay, so I've got a circle, and x is greater than 0, y is also greater than 0. The area of this rectangle would be 2x. Since x is only the positive distance, I need 2 of them, times y, okay, length times width. Y is the square root of 4 minus x squared, so 2x times the square root of 4 minus x squared would be the area of the rectangle. The perimeter of the rectangle would be 4x plus 2y. Okay, 4x because x is only covering half the distance. It'd be 2x plus 2y if this whole thing were x and this whole thing were y. Y is the square root of 4 minus x squared. And so 2x plus 2 times the square root of 4 minus x squared. Okay. The area A as a function of x is given by the 2x times 4 minus x squared. Okay, and I've got that already entered. And so if I hit second trace, and I want to find the maximum area. So I want to find the maximum area. Okay. Well, here's a max curve. .414. So the area is going to be largest when x is root 2. Okay. How about the perimeter? When's the perimeter going to be the biggest? Well, I want to maximize x by using a different let's see here, 4x times plus second square 2 times the second square root of 4 minus x squared. Okay. So I want to maximize that function, and okay, let's see here. So second calc, maximize, go left bound, right bound, guess. 1.79, 8.94. Yeah, okay. So the perimeter is going to be taken on a different shape when the area the area of the rectangle is largest. Okay. So we can do problem 10 here real quick. Problem 10 is where it says that a circle of radius r is inscribed in a sphere. See the figure. Express the area A of the square as a function of the radius r of the circle. And then express the perimeter P of the square as a function of r. Okay. So the area of the rectangle would be 2r, since r is only covering half of the length, and the length and the width are going to be the same. 2r times 2r, which is 4r squared. The perimeter is 2r, but I've got 4 sides wrapping around, so 4 times 2r, which would be 8r. Okay. And when we stop right there.